In order to benefit from this video, whenever you see a question, pause the video and attempt the question, and then play the video and compare your answers. If you got it wrong, I would advise you to repeat the question. Then by the time you are done with this video, you will be good in trig identities. So everything from the basics to the high level will be covered in this video. So let's begin. Alright, starting from the basics, here's the first question. So you can pause the video and attempt it, and then you compare. Alright, so now, whenever we see tan in trigonometry, you have to attack it immediately. So the first thing you do is to attack tan. Whenever you see tan in a trig question, attack it immediately. So then this becomes, okay, let's just do this. So this becomes sine x, so this is still sine x. Then we're going to have all over, then we're going to have cos x. And then we're going to have, so tan is going to change into sine x over cos x. So this is going to become over cos x. So now notice that we have got a fraction. Once one thing is a fraction, everything else becomes a fraction. So now notice that at the denominator, we're dealing with multiplication of fractions. So what makes people struggle in trig is, number one, changing identities. Those who know how to change identities. Number two is just simple basic mathematics rules. So once you know the basic mathematics rules and you know how to change identities, you can do anything you want in trig, you will still get the answer. So whenever you're multiplying fractions, the first rule is check if anything cancels. Whenever something is the same but one is up and the other one is down, they will cancel, whether they're in the same fraction or different fractions. So whenever one thing is up and the other one is down, they cancel. So now notice that this cancels leaves 1, this cancels leaves 1, right? So once we have cancelled, then you multiply along the same line. Numerator multiplies numerator and denominator multiplies denominator. So notice that we're left with 1 here. So 1 times sine x is just sine x. And then 1 times 1 is 1. So eventually we have sine x over 1, which there is no need to write over 1. We just write sine x. So basically on the next step, we'll end up having sine x all over sine x, right? Because what was left out of this stuff is sine x. Then this will cancel out and become 1, because whenever something is the same but one is up and the other one is down, they cancel, right? So your answer is 1. All right, let's move on to the next level. By the way, there is a mark for changing tan into sine over cos. So whenever you see tan, you know that you already have a mark. All right, here is another one. You can pause the video and attempt it. So the minute we see tan, we know we have to attack it immediately. This will change into, so tan squared is the same as sine squared x over cos squared x, right? So it's going to become sine squared x over cos squared x. So whenever we've got this, whenever we've got 1 minus sine squared x, notice that 1 minus sine squared x is actually cos squared x, right? Or if we have 1 minus cos squared x, then it is sine squared x, right? So then this is sine squared x. Okay, let's just do this. So this is going to be sine squared x. So this must be known. You have to know both directions. You have to know how to convert. You have to know to convert this to this or this to this, right? According to the need. So sometimes we move from this side to this side. Sometimes we move from this side to this side. So make sure you memorize them both directions. And then another thing you have to know is that sine squared plus cos squared is 1, right? So sometimes we can actually convert it from this direction to this direction, but it's a very, very rare case, right? So this one, mostly we always convert it from sine squared plus cos squared to 1. But these ones, you have to know them both directions. Sometimes we convert this to this, sometimes we convert this back to this. So make sure you memorize it. Therefore, every time we see 1 minus sine squared x, we know that this will become cos squared x. So notice that this is multiplication, right? So brackets means multiplication. So this is the same as times cos squared x. So once one thing is a fraction, everything else becomes a fraction. So according to the multiplications of fractions, you have to check if something is the same and one is up and the other one is down. So notice that this is the same, one is up and the other one is down. So therefore they cancel, right? So this cancels, leaves 1. And all right, let's just do that. So this cancels, this leaves 1. This cancels and leaves 1, right? So now what you're left with, you multiply, right? So the numerator multiplies numerator. So sine squared times 1 is sine squared. and then 1 times 1 is 1. So there is no need to write over 1, right? So the answer will be sine squared. And there we have it. Let's go for the next one. Alright, here is another question. You can pause the video and attempt it. So, do we really have to multiply? We can multiply and get the answer. You still get your full marks, right? But notice that it will be a long cut. There is a better way to do this. Now, notice that we've got similar things, right? The only difference is that we've got a plus on one and a minus on the other. Whenever you see this, the answer is just difference of two squares. For instance, if we had a minus b and a plus b, there is no need to multiply. The answer is just going to be the square of this minus the square of the other thing. Because notice, if they gave you this and they say factorize, you would actually factorize it by opening two brackets and putting a plus on one and a minus on the other, right? So whenever you see brackets like this and we've got similar things, but on one there is a plus and on the other one there is a minus, the answer is just the difference of two squares. So therefore the answer will just be the square of this thing, which is 16, minus, not plus, because it's not the sum of two squares, but it's the difference of two squares, right? So it's going to be minus the square of this thing. Now, a lot of students make mistakes by saying 4 sine squared, and this comes out wrong, right? Because you actually have to square everything. So don't only square the variable, also square the number. So therefore, this will become 16 sine squared theta, right? So now, notice that from here, we've got a common factor. Whenever you are tempted to minus this thing, but you see that they cannot minus because this is attached to this thing, then you know that you have to factorize. So when you factorize, the common factor is 16. So when we open brackets, we just say 16 divided by 16 is 1. And then we're going to have negative this stuff. We're going to have negative 16 sine squared divided by 16. 16 and 16 will cancel. We'll eventually be left with negative sine squared theta. So now notice we have something familiar. Identities, right? So now 1 minus sine squared is cos squared. So this eventually becomes 16 cos squared. And this is the final answer. Alright, before we go higher, let's just quickly attempt this because apparently there are people who struggle in this. So let's proceed. So now notice that we see tan. Immediately when we see tan, we know we have to change it. Therefore, it's just going to become 1 minus. So now notice this is tan, right? So this is just going to be sine x over cos x. So let's just do this. So over cos x. And then now over here, we're going to have cos x and sine x. Now notice that when one thing becomes a fraction, everything else becomes a fraction, right? So this is over 1 over 1. So we have to deal with multiplication before subtraction or addition, BODMAS, right? So now notice that whenever one thing is up and the other one is down, they cancel, right? Because there's multiplication of fractions, so we have to look for similarities. So since one is up and the other one is down, they just cancel. And then now eventually these two will multiply because they're on the same line, they can cancel, so it will become sine squared. So therefore this will become 1 minus sine squared. And then therefore notice that this is an identity. So this eventually will become cos squared. And there we have it. So let's go higher. Alright, here is another question. Pause the video and attempt the question. So now, notice that we've got subtraction of fractions. Whenever you've got addition or subtraction of fractions, you just apply the rules of adding or subtracting fractions, right? However, we've got tan here. So if you apply those rules before changing tan, you can make things more complicated. So my advice is whenever you see tan, attack tan first, right? So tan is sine over cos, so therefore this remains the same. So this is just this stuff, and now here we're going to have cos, right? The same stuff. Now here we're going to end up having sine over cos, so there is a mark for this, so don't skip this step. Now notice we've got a small problem. We've got a complex fraction. What is a complex fraction? A fraction with two or more lines. That is a complex fraction. So whenever you've got a complex fraction, you have to convert it into a simple fraction. So how do you convert it into a simple fraction? Well, whenever you've got a over b divided by c over d, right? This is division, right? Whenever we've got division, the first one stays the same, right? This stays the same, and then the second one changes. So what is down goes on top, what is on top goes down, right? And then it becomes multiplication. So this is called the tipping times method, right? So since here nothing cancels, whenever you're multiplying fractions, you check if something cancels. If nothing cancels, you just multiply them along the same line. Numerator multiplies numerator, denominator multiplies denominator. So that's tipping times method, right? So just one more example. So let's just say we've got A divided by B over C. What will you do in this case? Now notice that this A, we have A divided by B over C. So therefore this A, you can convert it to A over 1, right? So A is the same as A over 1. So this is going to be divided by B over C. So according to division of fractions, the first one remains the same. So it's still A over 1. And then we're going to say times. But the second one changes, right? What is down goes on top. What is on top goes down. And then we have it, right? Then we just multiply along the same line since nothing cancels. So A times C is just AC, and then 1 times D is just D, right? So let's apply that to this stuff. So let's apply it. So now notice that we have got cos divided by sine over cos. So what will you do? So this will just become cos over 1 divided by sine over cos, right? So now we can apply the tipping times method. So the first one remains the same, right? And then the next one will change. So we change the division sign into multiplication. So the next one will change. So what is down goes on top, and what is on top goes down, right? So there we have it. So what is down goes on top, what is on top goes down. So notice that nothing cancels, right? In multiplication, we always have to check if something cancels before we multiply. Now notice that nothing cancels, so all we can do is just multiply along the same line. So cos times cos is cos squared, and then 1 times sine is sine. So therefore, the answer is just going to be cos squared over sine, right? So over sine. Alright, so let me just get rid of this particular portion. Alright, so now notice that we have simplified it, right? So we've changed it from a complex fraction into a simple fraction. So now we can apply the rule of subtraction or addition of fractions, right? So what is the rule of addition of fractions? The first rule is that if the denominators are the same, right? So let's just do this. Let's just say this was 4. So if the denominators are the same, you keep the denominator the same, right? But then you add the numerator. So you just keep the denominator as 1, but then you add the numerator. Okay, so this is supposed to be 4. So I hope you get it, right? So if the denominators are the same, you just keep it as 1, and then you add the numerator. So this works for both addition and subtraction. But what if they're different? So if they are different, if you know how to deal with this, you can use your own method, absolutely nothing wrong. But if you don't know how to deal with this, then I would advise you to use this method. So if you have something like this, notice that the denominators are different. What do you do if the denominators are different? Well, the first thing is that you will just multiply the denominators, then this is going to be xy, and then you cross, right? So make sure you start with the numerator that comes first. You cross by starting with the numerator that comes first. So 2 times y is 2y, and then 3 times x is 3x. So that's how we apply the butterfly method. So this is known as the butterfly method. All right, so now looking at this, notice the denominators are not different. The denominators are the same. So we don't have to use a long cut, right? We don't have to cross, or rather we don't have to multiply then cross, right? We'll be wasting our time. We'll be taking an extra step. So the denominators are the same, meaning that we just keep them as 1. So our answer is just going to be sine x at the denominator, and then at the numerator is going to be 1 minus cos squared x. So now notice that this is an identity. So since it's an identity, this is going to end up becoming, so 1 minus cos squared is sine squared, right? So sine squared, and then at the denominator we've got sine x, right? So notice that here we've got sine squared, and then we've got sine. What do? This cancels with one of them. So eventually we'll be left with sine x. Alright, there we have it. Let's go for another one.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths, or whether it is the situation where you're good in maths but want perfection, Take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Watch the video that is found at the end of this video in order to know the prices and the updated contact details just in case these ones have changed. Alright, let's proceed. Here is a question. So you're given this and you're asked to prove the identity. If you can solve this using two methods, I would like you to solve it for practice sake because those two methods will be important for the high level. You can pause the video and attempt the question. So now when you look at this, notice that we have to choose, right? So let's start with that part. When we say prove the identities, we have to choose rather one of the two sides. So the advice is choose the most complicated side, which is left hand side. It is more complicated than the right hand side. So the advice is choose the more complicated side. So I chose the left hand side. So now I'm going to use two methods, right? So let's just talk about the first one, the easy one. Notice that we have got two terms, right? This is one term and this is another term. So notice that we can factorize. So we can only factorize when something is common in all terms. So in this case, there are two terms and there is something that is common in both terms, which is cos. So notice that we're just going to factorize cos. Now after factorizing, I just say this divided by this is cos squared x. Right? So now we have got positive this stuff divided by this, right? So cos and cos will cancel. Then eventually we're going to be left with positive sine squared, right? And it's simple. Notice that this is an identity, right? Remember, cos squared plus sine squared is 1. So therefore, this is going to end up becoming cos into 1, which is just cos. And we're done. We have proven it. Then we'll say, therefore, left-hand side equals to right-hand side. So we're done. All right, let's talk about the second method because it's going to be important. So now notice that we have used the factorizing method. The second method, I call it the changing method. So it's going to be important. I'll show you where it's important. So let's use the changing method. What is the changing method? Notice that this says cos, but this one is speaking the sign language. So we have to convert this to speak the same language as the rest. So notice that this is cos cubed and then this is cos. So we're going to change this to cos, right? So notice this is the same as 1 minus cos. So 1 minus cos squared, right? So it's an identity. Remember, 1 minus cos squared is sine squared. Sine squared is also 1 minus cos squared. So you have to know both ways. So this is important for the changing method, right? So you have to know both of them. So notice that after changing, we always distribute and we always put brackets so that it reminds us to distribute. So this is still cos cubed. And then we're going to have cos x. And then this side, when we multiply, it's going to become cos cubed. And every time we change, there is distribution. After we distribute, there is always like terms, either, or rather, not always per se, but it's either something's going to add or cancel, right? So every time we change, there is distribution. After distribution, something will either add or cancel. In this case, they cancel. Notice that we've got like terms, so the answer is just cos x. So this is important, right? That you know the factorizing method does not mean you must not know this method. There are other places where you can't factorize, but you can change. There are other places where you can't change, but you can factorize. So let's go for another question. All right, here is another question. Pause the video and attempt the question. All right, here is a question. You can pause the video and attempt it. So we're given a question. We're asked to prove that 1 minus tan squared x times 1 plus tan squared x is equals to 1. So we choose the most complicated side, which is the left-hand side. So we're going to say left-hand side. All right, so now notice that we see tan. So whenever you see tan, you have to attack it immediately, right? So, and this is also an identity, so you can also change it. Notice that we've got 1 minus tan squared x. It's just clear in front of us that it's 1 minus tan squared x. This just becomes cos squared x, right? So here we've got 1 plus sine x, rather sine squared x, over cos squared x, right? Because that is what is equals to tan squared x. So some people distribute. It's good. You can do that also, right? But I prefer using the rules of adding fractions. Notice that here we've got fractions adding, right? Once one thing becomes a fraction, everything else becomes a fraction. So we can add fractions. So now here we still have cos squared x. So now notice here. So notice that here we've got addition of fractions, but the denominators are different, right? What do we do if the denominators are different? We just multiply them. So we multiply them. 1 times cos squared is just cos squared. And after multiplying, we cross, right? So 1 times cos squared is cos squared. And then this side, we're going to have sine squared times 1, which is just sine squared. So notice that cos squared plus sine squared is the same as sine squared plus cos squared, right? So this is literally 1. So that is literally 1. So this part, I want you to notice something about this part as well. Notice that we've got multiplication of fractions. So if this is a fraction, everything else becomes a fraction. And notice that whenever one is the same, rather whenever they're the same but one is up and the other one is down, they just cancel, right? So eventually our answer is 1. Alright, let's continue. Alright, let's go for this question. So it looks pretty simple, however, most people will not be able to solve it. Alright, you can pause the video and attempt the question. So when you look at this, I'm going to choose the left hand side because it looks more complicated, so I'm going to choose left hand side. So notice that when one thing is a fraction, everything else becomes a fraction, right? So we're now subtracting fractions with the denominators that are not the same, so we just multiply them. So sin x times 1 is sin x. And then we just cross, right? So 1 times 1 is 1, and then we have minus, right? So sin x times sin x is sin squared x. So pretty much simple, right? So we've got 1 minus sin squared x is cos squared x, right? So this is where a lot of people will get stuck, literally. So if you did everything right, a lot of people get stuck here. Some will actually get this, but some get stuck. So how do you convert this to this? There are two skills you can use. Let me show you the escape method first, and then I will show you, okay, let me show you the complicated one, then I'll show you the escape method. Okay, so I don't believe in the word complicated, I'm just talking about relatively. So notice that cos squared is actually the same as cos times cos, right? So cos squared is cos times cos, so you can actually split it. So now this is sin x. So now notice this actually becomes cos over sine, right? Cos over sine, notice sine over cos is tan, but cos over sine is 1 over tan, right? So therefore, in this particular portion, now we're going to have 1 over tan. Okay, so I don't know why is it not writing. It's being slow. Okay, so now this is going to be 1 over tan. So I meant to write 1 over tan. All right, so now we're going to have 1 over tan cos. Sine over cos is tan. Cos over sine is 1 over tan. So now we have 1 over tan times cos, right? So this is the same as cos over 1. So obvious, multiplication of fractions. Here nothing cancels. So if nothing cancels, numerator multiplies numerator, and denominator multiplies denominator. So there we have it. We have the right hand side. But now let me show you the escape method. So let's just say you are stuck, right? Let's just say you couldn't do this. So what if you didn't think of splitting them and noticing that is 1 over tan, right? What if you didn't think of it? So here is an escape method. So apparently you are also allowed to choose the right hand side after choosing the left hand side. So we chose the left hand side, this is how far we went. So you can also choose the right hand side. You can also say right hand side. So this is the escape method. So our right hand side so far is cos over tan, right? So it's cos over tan. So now notice that tan is the same as sine over cos, right? Whenever we see tan, we are taking it immediately. So this is sine over cos, right? So now we have a complex fraction, we have to turn it into a simple fraction. So this is the same as cos over 1, right? Over 1 divided by sine over cos. And cos over 1, okay, this is cos over 1 divided by sine over cos becomes cos over 1 times, right, whatever is down goes on top, and whatever is on top goes down. Now notice that this is actually nothing to cancel. Here's multiplication, but there is nothing to cancel, so we just multiply along the same line. So cos times cos is cos squared, right? Let me write it over here. So it's going to be cos squared, and then 1 times sine is sine. So notice the similarities. Notice that we got stuck before at this point. When we chose the right hand side, we also went as far as this point. So we've proven that is the same thing, right? So I just wanted to show you that. So notice that we've proven that is the same thing. So we can say therefore left hand side. So therefore left hand side. Okay, forgive my handwriting. It's equals to right hand side, right? So it's that simple. So that's your backup method. So if you get stuck somewhere, as long as you have applied the rules correctly, you can also go to the other side of the equation and write it as well and simplify. Then once you have proven that they're both the same, then you're done. Left hand side is equal to right hand side. Here is another question. You can pause the video and attempt the question. So I call these long fractions. A fraction with many things, right? So whenever you see long fractions, you should apply either the changing method or the factorizing method. So sometimes the factorizing method works and the changing method doesn't work. Sometimes the changing method works and the factorizing method doesn't work. So when you look at the numerator, which one works? The factorizing method works because we've got two terms and we've got something that is common in both terms. The changing method doesn't work. So here in this case, we can just factorize. So we factorize, and then now notice we say cos divided by cos is just 1, and then minus cos cubed divided by cos is just minus cos squared, right? Because it cancels it. So this will cancel with one of them, so it's left cos squared. So this is actually squared. So we're going to have cos squared. And then at the denominator, which one works? Notice that we have got two terms and we've got something that is common in both terms, right? So the factorizing method works. Notice, however, that the changing method also works because we've got cos, cos, and then this one is sine, so we can change it to speak the same language as the rest. So the factorizing method is easy, so I'm going to use the changing method just so that I can show you both skills, right? Because I assume that you know the factorizing method. Besides, we applied it at the numerator. So at the denominator, let me apply the changing method. So this is going to be 1 minus cos squared, right? So it's a must to know both of them because sometimes factorizing method doesn't work and changing method works. So now notice that so I factorized at the numerator. At the denominator, I changed. Every time we change, there is always distribution, right? So there is always distribution. So this is going to become, okay, so let's just write this. This is cos x, and then we've got 1 minus cos squared x. And then we have all over, okay, let's just make it a little bit better. So we have, now notice this will distribute, so we're going to have cos x, and then we're going to have, when this multiplies, one is just cos x, and then when it multiplies, we're going to have cos cube x, right? So that's what we have. Now let me just verify, and then yeah, cos cube. So now notice that this cancels. Every time we change, there is always something that is going to add or cancel. So eventually, what are we left with? So eventually we're going to be left with cos x, and then we're going to have 1 minus cos squared x. So this is going to be cos cube x. So now notice that this will cancel with one of them, so we'll be left with cos squared x, right? So eventually, matter of fact, there is no need for me to erase. Let me just write it. So let's just do this. So eventually we'll be left with 1 minus cos squared x over cos squared x. Now 1 minus cos squared, we know it's sine squared, right? So it's just sine squared x over cos squared x. And this will give us tan squared x. So therefore left hand side. Alright, here is another question. You can pause the video and attempt the question. So what confuses most students is actually this particular portion, right? So some people will try and take this to the other side and then square both sides. So this also appears in past papers. In another past paper, I was doing the first time I saw this thing, I saw it on top of a fraction and stuff. And then I noticed that trick. I actually thought for a while and then I noticed that trick. So what is the trick here? Okay, of course, first let's just change tan. Whenever we see tan, you know that we have to change tan. So let's just change it first. So let's do this. So this is going to be sine over cos, right? So eventually we're going to have that. So 1 mark for that. Okay, so now the trick here is that you just have to notice that this is an identity. Once you have noticed that it's an identity, we're going to have cos squared, right? And once this is cos squared, immediately the square root cancels with the square. Now notice that the square root cannot cancel when things are separated by a plus or a minus. That is breaking mathematical rule. That's another thing you have to be careful of, right? That's what I've seen done by a lot of students. So the square will eventually cancel the square root. So that's the trick. So if they give you something like this, let's just say they give you something like this, so 1 minus cos squared, right? If they give you something like this, all you have to do is just to change it into sine squared, and then the square cancels the square root, then you're done. You're left with sine x. All right, so let's just proceed. So eventually this is just going to become cos, right? So let's simplify this fraction. So if we simplify this fraction, this is the same as, let's just do it on the side. There is no mark for that. So this is the same as sine over 1 times. So this is going to be cos on top and sine down, right? So now notice the same thing cancels, right? So eventually the answer here is just cos. So we're going to have cos. So now this is going to be minus, now this is just going to be cos. Remember the square root cancelled with the square. So now notice that the answer is just 0. So we're done. Left hand side is equals to right hand side. Right, let's proceed. Alright, here is another question. So you can pause the video and attempt this question. So notice that this is long fractions again, where we can either factorize or change. Now notice that when we look at the numerator, we can't factorize this time because we have got 3 terms, but cos is common here and here, but not here, right? So we can't factorize. So we don't have something that is common in all 3 terms. So we can change because this says cos, this one says cos, and this one says sine. So we can change. So now then this is going to be cos squared. So we're going to have cos squared minus cos, and then this is going to become 1 minus cos squared. So every time we change, we have to put it in brackets, right? And don't use multiplication sign when you change, it's better brackets. So this is going to be, okay, so now notice at the denominator, what can we do? Can we factorize or change? Notice that this time we can't change because, yes, this one says sine, and then this one says cos, and this one says sine, but we can't change this to sine because it's not squared. We can only apply the changing method if there is a squared. But notice we can factorize because we've got a term here, we've got a term here, and we've got something that is common in both terms, which is sine. So therefore, we can factorize, right? So let's factorize sine. So if I factorize sine, what will enter the bracket? Notice this whole thing divided by this, these two will cancel, and then now I'm going to be left with 2 cos. And then positive sine divided by sine is going to be positive 1 because sine will cancel sine. It's literally going to be left 1. So now every time we change, there is always distribution, and after distribution we look for like terms. So this is going to be cos squared, and then it's going to be cos. So when we distribute, this is going to be minus 1, and then this is going to be cos squared x, right? So that's what we have. So let's do this. So let's just do this. So okay, fine. Yeah, it looks weird, but anyways, let's just continue. So this is going to be 2 cos x plus 1. All right, so every time we change, there is distribution. After distribution, we look for like terms. So notice that this and this are like terms, but this time they don't cancel, this time they add. So now we're going to have 2 cos squared x, right? So this is going to be minus cos x minus 1. So this is going to be it. So we're going to have sine x and then 2 cos x plus 1. So now we've got a new problem. notice that we can't change anymore, right? Now, if you look at this, you will see that this is actually quadratic, but in trig. So sometimes we actually do have quadratic, but in trig. That's what I like about this exercise. So we've got quadratic, but in trig. So what do? We have to factorize it using quadratic. Now, what if you don't know how to factorize when there is a 2 in front? Okay, so I put the video on the top right of the screen, and also at the end of the video, right? Where I show you how to pretend as though you're factorized. But anyways, let me just do something. So we can use the k method as well. So if we take the smaller one, we say let cos be k. So we can do that. So we can say let cos be k. You can do this on the side because there is no marks for this, right? So cos is k. So if cos is k, cos squared is k squared. So it means this is going to be 2k squared minus k minus 1. So how do we factorize this? You can use the quadratic formula and then pretend as though you're factorized. So let me say something. If I use the quadratic formula, if you use the quadratic formula, your first answer will be k is equals to 1, and your other answer is k is equals to minus half. So what do? You can take this to the other side of the equation so that it's k minus 1 equals to 0. Then this is what you put in your bracket, literally. So you have just pretended as though you're factorized. So, but instead of writing k, we write cos. So it's going to be cos minus 1. And then this side now we've got a problem. It's a fraction. What do we do if it's a fraction? Because we've got this. So if we've got a fraction, what you're going to do is that you're going to make this over 1. And then you cross multiply. So this is going to be 2k is equals to minus 1. So once you have gotten rid of the fraction, you can take this to the other side of the equation as well. So now you're going to have 2k plus 1 is equals to 0. Once you have equals to 0 there, you can now put this in the equation. But instead of us writing 2k, we can write 2 cos. So this is going to be 2 cos plus 1. So there we have pretended as though we factorize. So all you do is just to use the quadratic formula and then work backwards. So you can watch the video for the full details. So let's do this. Alright, so now this is going to be sine x, and then we're going to have 2 cos x plus 1. So how you know you're on the right track is every time you factorize, the brackets must be the same. So if there's no bracket that looks the same, then there's something wrong. So this cancels with this. Now we're almost done. We have cos minus 1 over sine. So notice a problem. We want it to be 1 over tan minus 1 over sine x. So another thing you can do is, if you want, you can use backup, right? You can also use the right hand side as well, and then it will end up becoming like this. But it can end up becoming like this. But another skill you can use is to split again. Notice that if you have got 2 plus 3 over 5, this is the same as 2 over 5 plus 3 over 5. Why is it the same? Because remember, if you're adding and the denominators are the same, you can just keep the denominators like that and add the numerator. So it's just working backwards. So I hope this was visible, right? This stuff is the same as 2 over 5 plus 3 over 5. So if we use the rules of addition, the denominator remains the same, and then we add the numerators. So that's how it is. So we're just using the same rule but backwards. So this is the same as cos over sine minus 1 over sine. So notice I'm already done, right? So we want it to be 1 over tan, and we know that cos over sine, so cos over sine is 1 over tan. So we're almost done, and then this is 1 over sine. So there we have it. Alright, here is a question. You can pause the video and attempt it. So if you got the other question correct, or if you understood the correction of the other question, definitely you should get this one correct. Alright, so now I'm going to choose the left hand side. So I'm going to choose the left hand side. Alright, so let's choose the left hand side and simplify. So notice that we have long fractions again, so we can either factorize or change. So let's look at the numerator. In the numerator, we can only change, we can't factorize, because we have 3 terms, and then sine is common here and here, but not here. So let's change. This one says sine, but this one says cos, so we change this one. So this is going to be sine squared x plus sine x. So we're going to have plus sine x, and then we're going to have, let me just write this better. So this is going to be plus sine x, and then we're going to have minus, then we're going to have 1. Okay, 1 minus sine x, right? 1 minus sine squared x. All right, so then this will be all over. So notice at the denominator we can not change, right, but we can factorize because we've got two terms and something is common in both terms, cos, right? So we can factorize cos. So if I divide this whole term by cos, cos and cos will cancel and we'll be left with 2 sine. And then minus cos divided by cos is minus 1. Alright, so now let's go further. So now after changing, there is always distribution, so let's distribute. So then this is going to be minus 1 plus sine squared x. Alright, so let's go further. So this is going to be, this is still cos x, and then brackets 2 sine x minus 1. Alright, so now this is going to be 2 sine squared x, right? Then it's going to be plus sine x minus 1, because every time we change there is distribution. After distribution we look for like terms. So this is going to be cos x. So already we know that when we factorize, one of the brackets must look like the denominator. So let's factorize. So let's just use the k method. This is going to be 2k squared plus k minus 1. So if we use, okay, so this time I'm not going to use the quadratic formula. I'm going to use my own method. So this is going to be, it's not really my own method. This is also widely used. So this is going to be this stuff. So when I factorize this by grouping, so I'm just using my own method. You can use any other method. So this is just going to be k, and this is going to be 1. And then if I factorize minus, so here I factorize minus, and then in brackets it's just going to be k plus 1. And then if the brackets are the same, I know I'm on the right track. So here I'm just using my own method. So so this is going to be 2k minus 1. Okay, so I factorized. So then, so you can use the quadratic formula and pretend as though you're factorized. But this is one of the methods of factorizing when you've got something in front of k squared, right? So instead of me writing k plus 1, I write sine x plus 1. And then I write 2 sine x minus 1. Alright, so then I know I'm on the right track because the brackets do look the same. So this is going to be 2 sine x minus 1. So now notice we can cancel, right? So therefore we're just going to be left with sine x plus 1 over cos x. Alright, there we have it. Alright, here is a question. So you can pause the video and you can attempt it. Alright, so now many people will get stuck here because of a certain skill that we have not applied before. So whenever you see similarities, notice that this is the same as this, just that one is up and the other one is down, and then this is the same as this, just that one is up and the other one is down, and then the signs are different. So whenever you see this kind of similarities, you have to apply, you have to rationalize. So what is rationalizing? So let me just rewrite this. So I'm going to choose the left hand side. So this is 1 minus sine x, right? So rationalizing, let's just do this, let's make it a bit better. So rationalizing is where you multiply by 1, but the 1, you will not write it as 1, you will make it look like the denominator. So we're going to have 1. Now here, instead of writing minus, we're going to write plus. So we make it look like the denominator, but we have to change the sign. So notice, this is still 1. The same thing over the same thing is 1, right? It's just that I've made it look like the denominator and I changed the signs. So that is rationalizing. If I chose the right hand side instead of the left hand side, I would have to rationalize the numerator. So I multiplied by 1. It's just that the 1 will look like the numerator with the opposite sign. So that is rationalizing, right? So this is what I would have done if I chose the right hand side. So right now I'm rationalizing the denominator, meaning that I make it look like the denominator but with the opposite sign. So why do we do this? So Notice something, we're doing it on purpose. The reason why we're changing the sign is because notice that this is multiplication, right? So nothing cancels, so meaning that we have no choice but to say numerator times numerator and denominator times denominator. Now notice that here it's two things multiplied by two things, so they're both in brackets, right? Now the reason why we change the signs is so that it can be the difference of two squares. Notice that these are the same, it's just that the signs are different. So the answer is just the square of this, which is just 1, minus the square of this, which is just sine squared. So we do it on purpose. That is rationalizing. The rationalizing is where we multiply it by 1, but we make the 1 look like the denominator, but with the opposite sign. So it depends. Sometimes we rationalize the denominator, sometimes we rationalize the numerator. So in this case, we rationalize the denominator, so we made the signs different, and the answer is just the difference of two squares. And then here we just multiply, but I'm not going to distribute for some reason. So if I distribute, I'm going to end up factorizing again. So notice that here, this is an identity. It is 1 minus sine squared, right? So that is why we rationalize, so that it can get to this. So this becomes cos squared. And then this side, there's no need to distribute, because if we distribute, we're going to factorize again. So now notice, this will cancel one of these, right? So it will eventually become 1 plus sine x. So 1 plus sine x over cos x. And notice that this is actually the right hand side. So we're done. We have made it look like the right hand side. So that is rationalizing.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.